I need some answer. Srinivasa Venkatan.
Yes, sir. 1 second, sir.
So would it be V by I?
1 minus a by cg.
I am asking why. What if the component is a resistance?
Would it be
So
V by I, sir?
V by I is Ohm's law. I am asking in terms of A. What will be the resistance? How will the resistance value change when you convert it using Miller's theorem? We have got CMI equal to 1 minus A into CF, right? Using Miller's theorem. What will be the same thing for resistance? I am asking. It is very simple. Ri will be equal to...
Sir, is it 1 by 1 minus a?
1 by 1 minus A into what?
Into cf.
I am not using CF here. Any other answer? I think nobody is following the class. So Ri equal to R by 1 minus A. Okay, so Ri will be R by 1 minus A. If I use inductor, Li will be L by 1 minus A. Since capacitor I am using 1 by j omega, it will be the reverse. 1 minus A into Cf. Okay, the same way, see in the next thing, I'll be writing the formula for output capacitance. So you know the formula for output Miller capacitance Z0 is given by Z by 1 minus 1 by A. So instead of Z0, I'm substituting 1 by j omega Cm0 equal to 1 by j omega Cf into 1 minus 1 by A. So if I cancel out 1 by j omega term on both sides, I'll be having Cm0 equal to 1 minus 1 by A into Cf. Okay, so this is going to be the expression for the capacitance, Miller capacitance at the output side. And the previous slide, if you see, this is the expression for Miller capacitance at the input side. Okay, and you can see that the capacitance depends on the voltage gain. And in the second case, in this expression for Cm0, you see, if the amplifier is going to have a very high voltage gain, if A value is going to be very, very large, for example, common emitter amplifier, you know, A value is very, very large. What will happen to 1 by A? What will happen to 1 by A? If A value is very, very large, what can you say about 1 by A? 1 by A will be very, very small. I can say 1 by A is going to, mathematically, I can say 1 by A tends to 0. If I put 1 by A equal to 0 here, I will get Cm0 is approximately equal to Cf. Okay, I can write Cm0 is approximately equal to Cf only in the second case because the voltage gain is very, very large. But in the first case, I cannot do that because it is 1 minus A. A value is very large. Even though I do 1 minus A, it is not going to get any simplified value anyways. But in the second case, since I have 1 minus 1 by A, if the voltage gain of the amplifier is very, very large, then 1 by A will become 1 by A will be a very, very smaller number. So I can assume 1 by A is going to be 0. So Cm0 is going to be 1 approximately equal to Cf. So input side you will have 1 minus A into Cf. In the output side I will be having only Cf. Okay, this is I am taking the approximate value of the Miller capacitance. So Miller capacitance, we have two capacitance: Miller input capacitance given by Cmi, Miller output capacitance given by Cm0. Okay, remember thing, whenever you these values come in derivation, we have to relate and say that this value corresponds, this is coming because of Miller effect or Miller's theorem. Okay.